Hi, so I'm demoing PA3 and PA4 in this video, which is the model converter and the model viewer for the engine. So I'm going to start by just showing off some of the key aspects of the model converter code. Um, so here is kind of the code. This is the FBX scene thing that we started with, and including Ed's modifications to kind of stuff all the vertex and triangle data into these vectors. I kind of followed that in order to do some stuff with the texture. Um, so I went to display texture. I found where we were kind of iterating over the texture files, and I just kind of put those names into a vector so I could do stuff with them later. So down here is the main processing. This is where I'd had all this code to kind of manipulate, massage the data for the vectors. You can see, okay, so down here, this is where I did some processing with the textures. Basically, I took that texture file and I opened up the TGA so that I could find out how big that file was, because we're going to need that information. And then I just kind of save that associated information for later when we actually have to write it in. So you see I'm kind of stuffing this into this texture info data structure. And all it does is it just kind of has the name of the file, how big it is, and then this buffer for the raw data. So yeah, so I even read in the raw data so that we can pack it into the TGA. So then down here, this is where I kind of take in the inputs. The inputs are pretty simple. It's just the input file, so the FBX, the output file, the Azul file, and then a T option, a flag to just say what texture are we using. So the number that comes after the T is what kind of texture you want. So you can find that in here. And by here, I mean here. The way I have it now, I'm kind of making sure that this list is in sync with the list of textures in my engine. So anyways, the general structure of the Azul package is it's kind of similar to what we did for vodka in the LIU. It starts with a package header. And right now, all I have is just in that package header, I just have number of chunks and the size of the whole package. I probably should put in like a name and I don't know, like the checksum. I just didn't really need it right now to get it working. But if I wanted to add that, it would be really simple. It would just be a matter of going into here, adding those two members here, those two fields, filling them out right here, and then writing it in. But you'll notice here when I make the package header, I'm actually just making this as 0. I don't know how many chunks are in this package yet. I don't know how big it is yet. So for now, I'm just going to write the package header in at the top just to kind of save its spot. But we'll come back and update it later. After the package header, I do kind of pairs of a chunk header and a chunk. So I do it in a specific order in the converter, but the order doesn't matter when it's read in the engine. So I have the verts, the verts, the triangles, the textures, and then the bounding sphere. Those are kind of my different chunks. For verts and triangles, it's Ed gave us the data. It's not that complicated. I create a special header. I fill in, the appropriate members, and then I write that header into, so I write that header into the file, and then after that, I write all the data. And it's pretty much the same thing for triangles. Now I have a verts header and a triangles header. I'll just point out really quickly that so all these different headers, they all derive from chunk header. Chunk header is just kind of has the default information. In this case, I make sure it has a type, which is one of these up here, and it has the chunk size. Just how much like raw data does it contain. So then for the verts header, I say it derives from chunk header, so it still has those data types because it's gonna need those regardless. But it also has an extra member for num verts. This will be really useful in the engine, and I'll kind of demonstrate it later. But for now, I'm just kind of pointing out that this is here. So for the textures, I do basically the same thing. The only difference is that there might be multiple textures. So I'm looping on it, and I have to make sure that each time I add a texture, I'm increasing the number of chunks, and I'm updating the size of the package as I go. But I'm basically, like 100 lines above, I read all the TGAs into buffers. I'm just grabbing those buffers again, and this time I'm writing them into the file. And then once I'm done with it, then I delete the TGA buffer. For the bounding sphere, it's a little unique because it only has the data in the header. There is no like raw data chunk under it, because all we really need is the center point and the radius. We'll kind of construct the sphere itself in the engine. And then at the end, this is where I seek back to the beginning. Now that I know the number of chunks and the size of the package, I can write it out. So I'll show here, I have this file, it's conversion lab. And this is my model converter, exe. So the idea is, it uses these FBXs and these TGAs. It kind of consumes those and it writes out these .azul files. So I could do a command line. I'll just show the batch file. So here's the batch file that I wrote. It's called converter. And this is all it does. You start it up and it just runs these commands. This way it gives you a sense of what's going on. You can see for Space Frigate, I'm giving it texture 5. For Astro Boy, I'm giving it texture 6. Buggy 7. Warbear 8. Warbear actually has 8 and 9 because it has 2 textures. So I skipped 9 to go to 10 for Robot. And this is kind of the general input. The converter.exe, the input, which is the FBX, the output, which is robot, which will become robot.azul, the T flag for texture 10, and then this at the end just to make it so it all gets piped into a separate file. It's kind of nice to have that information in case I want to look back on stuff, but it also just makes the conversion a lot faster. So I'm going to run this. You can see it is converting. Space Frigate was really quick. Astro Boy is taking a little bit longer. Or I'm sorry, Space Frigate. Yeah. Space Frigate. Oh, now I'm getting confused. Okay, yeah. So the Astro Boy was taking a little bit longer, and then Buggy, then Warbear. So it says the name as it's converting it. Okay, and now it's done. So if you look, I'm going to sort by date modified. You can see Warbear, Robot, Buggy, Astro Boy, and Space Frigate. These were all done at 12:41 a.m. So you can see it on my clock here. I'm going to copy these, and that's basically all I have to show for the converter. So now it's time to go into the engine. I'm going to find my engine code. Here it is. And let me bring up the folder. So you can see my old Astro Boy in here. I'm just going to paste this in. It's going to say it already has these files, so I'm going to replace them. Now just to verify, the names of the files are Robot, Space Frigate, Warbear, Buggy, Astro Boy. And then in my main function for my engine, or my main file, main.cpp, or no, it's game.cpp, sorry. You can see I'm loading these. I created a class called custom model. And it's these exact names: Space Frigate, Astro Boy, Buggy, Warbear, Robot. So what happens when I make a new custom model? Let's go and find out. So it basically looks like other models. It starts out by doing priv create VAO. although it's really doing a lot more than creating a VAO. And this is a horrible function that really needs to be broken up. And I originally did have it broken up, but I was having all these compile errors because I was trying to pass the handle between, and it was just kind of messy. So I just did it like this for now, and I tend to break it up later. But this is how it works. So first it reads in the file name. So imagine that you were seeing frigate. In fact, why don't we just do it? So I'm going to step in. Okay, and we're going to step in to create VAO. So first it opens up the Azul file, and it reads in the package header. So we can look at the package header, and we can see, okay, there's 4 chunks in this. The size is 806,000 bytes. Is that kilobytes? Yeah. And then now that we got that information, we can start reading in the chunks. So I already know there's going to be 4 chunks. So I just do a for loop that says countdown from 4. We're only going to do 4 times. We start with a chunk header because we know it's going to be some chunk header. It might be the texture header. It might be the vertices header. The idea is we could change around the order in the converter, but we know that order is going to remain constant. Or no, I'm sorry. That order might change around in the converter, but it doesn't really matter what order it is here because we can just check what type of chunk we're dealing with. So, so what I'm going to do is I'm going to grab that chunk. And when I look at that chunk, I see, oh, it's the vertex chunk. So I'm going to seek backwards to the beginning of the chunk, and I'm going to read that in again. And I say, okay, it's a vertex chunk, so I go down to the switch statement, and this is where I handle unpacking the vertices. Now what I really should do is make each of these cases into their own functions. But like I said, I was just having some trouble with it at the time. And here it's not super complicated. Now that I know I'm dealing with a vertex header, I basically convert that chunk header into a vertex header, and I get some more information. So here's where I read it as a vertex header. I check the number of vertices. There's 511. I create a temporary buffer, and I start just filling out that buffer of vertices. Once I get that buffer, I can send it to GL and get all that stuff squared away. And then I'm done with that vertex buffer, so I get rid of it. So now we look at the next chunk, and we see, okay, we're having the triangle buffer. So it just keeps going like this. And we're going to keep going. So next we'll do the triangle buffer, and we'll do the texture buffer. For the texture buffer, texture chunk. For texture, what I'm doing is I'm unpacking the TGA. So the TGA is embedded in the Azul file. I'm writing it out back into the PA4 source directory so that then I can turn around and read it in again, right? So I create a separate file handle. I write out the TGA. I close it. And then I just add the texture by supplying the file name. So it's a little inefficient. I should probably just do something that hands that buffer, the TGA buffer, off directly. But this works for now. In general, I kind of like this style of dealing with these chunks. I think the whole thing of having a chunk header and then having other headers that derive from that is kind of elegant. I like it. This specific way I'm doing it right now, I realized after I'd written it, is a little awkward because I'm doing a lot of reads. From this space frigate.azul, I'm doing a lot of reads. And really what I should do is I should just read the whole thing in once, and then I can just do some pointer arithmetic instead of doing seeks. And so I think that's what I'm going to do. That's one of the big things I want to do next. I don't think it will be that hard, but it will take some time, and I think it should help out a lot in terms of performance stuff. Anyway, So it'll do that for all the different models. I'm gonna play through. This is kind of the scene I have right now. Just kind of have a bunch of random models floating around. So here's the buggy. This is the space frigate. So let's see. The buggy and Astro Boy are using a flat texture with nothing to do with light. This space frigate right here does change its texture light. It's not super sensitive to light, but you can see like it does have like there. You can see that shadow's pretty deep. Compared to that frigate, so I'm doing multiple instances of this model, has a flat texture, and I'm slowly flying towards it. There we go. I'm just gonna fly all the way around it so you can see that all the triangles are there. This guy right here, this is a robot I got from the student directory. So he's got like 4,000 vertices or something like that. So he's pretty complicated in it, and he looks good. And let's see. And then there's the war bear. So there's that huge war bear over there, and he's all dark. Oh man, I lost him. Well, I'll go over this war bear first. This war bear is texture light. It looks like the texture is just kind of missing or blank, but if I get around to the right angle, he just lights up all of a sudden. So I think I just need to fix the way my lighting works. Add in some kind of, oh my god, I forgot what it's called. Like an ambient light, some kind of flat, instead of just a point light, I need another type of light. Whereas this war bear is a flat texture. It's just the same brightness all the way around. Okay. And I'm just going to go back to main to show off some of this, how I actually instance these objects. So back in main. I'm getting there. Oh, sorry, it's called game. So I originally created these models. I import the model just by doing the name, and then I add it to the model manager. I go down, way down here. I say, okay, I want to make this ship. I want to make an instance of the ship that doesn't react to light. It just shows the texture. And I set this kind of stuff for, the position of the ship. This is kind of irrelevant right now, but I also made it smaller, and then I added to my manager. Here's where I'm making the ship, and I'm saying, okay, I want this version of the ship to react to light. It should react to light. So it's using a different graphics object, and a different shader. And then I just keep going. I just kind of add all the rest of these in. So this is boy. Yeah, Astro Boy. Astro Boy, the buggy, the bear, the two bears, and the robot. I just added these all to the game object manager, and then the game object manager updates, and it deals with cleaning them all up together when I do destroy. I guess one thing I'll show, just to show this here, I'll show some of the cameras working a little bit. I just have a couple set up. Oh, my cameras are not working. Alright, I must have messed with the key bindings on that. Well, I'll sort that out later. But you can see at least memories tracking's passing. So I guess I need to make sure those cameras are working. The main thing I need to do right now, which I just didn't really have time to get totally finished, is implement the bounding spheres. I know that I have the bounding sphere information. I've checked it, and I'm pretty sure of how I'm importing it. It's just the calculations to how to do it and how to have it adjust its scale and translation and rotation with the game object associated with. I don't have quite down yet. I also technically I still need to get it so I can switch textures on objects. But I know I can at least have one texture object. And I think my models, all the triangles are there, so I'm feeling really good about that. And let's just see. Okay, yeah. Anyways, so that's what I had for my viewer and converter. Thanks.